let's go ahead and get started. First of all, thank you guys for coming, and welcome to Worth Publishers TLC Symposium Series with Daniel Schacter of Harvard University, who is an author of two of our intro psych books, Psychology 3E and Introducing Psychology 3rd Edition, with his colleagues there at Harvard. We're starting right now. Just a quick note on audio: if you're having trouble connecting, feel free to shoot me a chat message. There is the toll-free number in the chat box as well, so when I move on from this slide, you'll still have it. As far as chatting goes, you can just click your drop-down at the box at the top whenever we start sharing the screen and click chat. Just know that if you click all participants, your chat question will go to everyone. If you click host, presenter, and panelist, it will go to Dan Schacter and I, and if you click host, it will go just to me. And just a quick note, my name is actually Lindsay. I'm in under someone else's account, so I'm Lindsay, not Elizabeth. At any rate, allow me to introduce Daniel Schacter. He is the William R. Keenan Jr. Professor of Psychology at Harvard University. Dan received his PhD from the University of Toronto in 1981. He taught on the faculty at Toronto for the next 6 years before joining the psychology department at the University of Arizona in 1987. Then he moved to Harvard University in 1991. His research explores the relation between conscious and unconscious forms of memory, the nature of distortions and errors in remembering, how we use memory to imagine future events, and how to enhance learning from lectures. Many of Schacter's studies are summarized in his 1996 book, Searching for Memory, The Brain, the Mind, and the Past, and his 2001 book, The 7 Sins of Memory, How the Mind Forgets and Remembers. Both were winners of the APA's William James Book Award. Schacter has also received a number of awards for teaching and research, including the Harvard-Radcliffe Phi Beta Kappa Teaching Prize, the Warren Medal from the Society of Experimental Psychologists, the Award for Distinguished Scientific Contributions from the American Psychological Association, and finally, election to the National Academy of Sciences. So without further ado, I give you Daniel Schacter. I will pass the ball over to you, Dan, so you can show your screen and PowerPoints.
Okay.
All right, and we're viewing your desktop. Perfect.
Okay, slides are up. Okay, well, thank you, Lindsay, and thanks to everyone for participating in today's webinar on memory from the laboratory to everyday life. All of us in psychology know that memory is of great concern to people in everyday life as well as in our laboratory studies, and this can be exemplified by many of the popular books on memory that are on the market: How to Develop a Superpower Memory, Quantum Memory Power, many others along those lines. And memory is also of interest in everyday life from a health perspective. Questions that arise in aging as to whether memory problems are normal or whether they're a sign of ominous disease such as Alzheimer's disease. So there's great interest, we know, in memory in everyday life. But nonetheless, most memory research is still laboratory-based. Today, what I want to talk about are two lines, recent lines of laboratory research that we've been conducting in my lab that I think at least have implications for everyday life. We're trying to make links to everyday issues. The first of these has to do with the effects of what I'm going to refer to as interpolated testing on attention to and memory for lectures. And the second concerns the effects of what I'll refer to as an episodic specificity induction. That's brief training in recollecting details of past experiences, the effects of such an induction on remembering, imagining, problem solving, and I'll say just a couple of words at the end about divergent thinking. Okay, so let's begin by talking about the effects of interpolated testing on attention to and memory for lectures. I'm sure that many of you who are listening to this webinar have faced an audience similar to the one that you're looking at now on the screen of eager young students seated behind their laptops awaiting your lecture. as much as we'd like to believe that all students every moment are intently focused on everything that we have to say, we know that if we look on the other side of those computers, that other things may be going on that aren't quite as relevant as we'd like to class. We may have people who are doing some online shopping, looking at YouTube, checking their Facebook account, various other things. This is all by way of means of suggesting that even though we want to believe that students are focused on everything we say in a lecture, we know that there is a tendency for students to become distracted and to engage in mind wandering. Mind wandering, we know from lots of very interesting recent research in psychology, occurs when people engage in thoughts that are unrelated to primary task at hand. There's a nice review on this by Johnny Smallwood in the Psych Bulletin 2013, and another even more recent one that he and Jonathan Schooler have written that just came out in the Annual Review of Psychology, two of the pioneers in this line of research. Now, mind wandering is interesting for many reasons, but it's of concern to us in this webinar because there are data indicating that indeed, as we might suspect as teachers, that mind wandering does occur during lectures and occurs pretty frequently. So there was a study published by Lindquist and McLean in 2011, summarized on the slide, in which they probed students using auditory probes in real time during psychology lectures about whether they were focused on the lecture or whether they were mind wandering. And what they found is about a third of the time the students indicated that they were mind wandering. Those bouts of mind wandering were more frequent toward the end of the lecture, around 44% of the time. At that point, they're indicating they're mind wandering as compared to about a quarter of the time at the beginning. And not surprisingly, the incidence of mind wandering is negatively correlated with learning of lecture content, but that, of course, is very important to us because we want to believe that students are attending our lectures in order to learn. There's been a more recent study the following year carried out by Evan Risco and his colleagues using video recorded lectures of various topics, psychology, economics, classics, in which students were either viewing the video recorded lecture alone, or they were in a classroom with other students, were probed 4 times during the course of the lecture, and they found roughly about a 40% incidence of mind wandering in response to these video recorded lectures. So it seems to be a very frequent phenomenon. And of course, we're interested in it because, as alluded to earlier, mind wandering can interfere with learning. That's what we think of as the primary goal of our lectures, is to enhance learning. So there's evidence from the working memory literature that working memory performance on a task requiring temporary maintenance of information can be really very severely impaired when people mind wander in the midst of the task. They lose the contents of working memory. And other work has indicated that when people mind wandering in the midst of reading a text, comprehension is reduced and subsequent memory is quite poor as a result. So all that led a couple of years ago, Carl Spooner and I to start wondering about whether there's anything that can be done to reduce mind wandering and increase attention during lectures. And it was an attempt to address that question that led to the line of research, a couple of studies that I want to tell you about now. The approach we took to trying to reduce mind wandering and increase attention and hence memory and learning during lectures relies on a phenomenon known as interpolated testing that some of you may be familiar with. We know that testing memory is one very potent way of increasing retention over the long term. Work by Roediger, Karpicki, and others has shown that. And interpolated testing is a kind of a variant on the basic testing effect, where there's some evidence that if you interpolate tests after each of several word lists in a basic word list memory experiment, the finding is that when people are expecting to be tested and they are tested, that can lock in their attention to the lists at a higher level than it would be otherwise, and increase memory for the final list consisting of novel items. So there are fewer memory errors made on the test of a final list of new items, and the idea is that because people have been intermittently tested on the previous list, they're paying closer attention to that final list and presumably mind wandering less, although mind wandering wasn't assessed in that study, and then remembering more at the end. So Carl Spooner, in fact, was involved in some of that early work, and so we decided to apply this interpolated testing approach where you interpolate a lecture with intermittent quizzes to video recorded lectures. And we used video recorded lectures for a few reasons. Number one, they're easy to control and to manipulate. Number two, they're relevant both to classroom learning and also to online learning, where video recorded lectures are widely used, standard parts of most online learning platforms. And indeed, it was in the context of developing some interest in online learning a couple of years ago that we really began thinking about this project. So what I want to tell you about first is an experiment that was one of two experiments reported in a paper published in 2013 in the Proceedings of the National Academy of Sciences, led by Carl Spooner, whose picture you can see on the slide. Let's walk through the basic methodology that was used in this study. We used a 21-minute videotape basic statistics lecture that focused on basic introductory concepts in statistics. The lecture was divided into 4 equal-length segments, roughly 5 minutes each, and the critical manipulation here is that those segments were separated either by brief tests on the previous lecture segment, math problems, or a restudy condition where the same questions were asked about the preceding content that were asked in the testing condition, but the answers were also given. There were 16 subjects per group, and for the tested and restudy group, they were probed about 6 items from each of the preceding segments. Again, the tested group is asked about them, they have to provide the answers. The restudy group is given the question and the answer. So participants in each condition are told at the beginning about what's going on. They're told the lecture is going to be divided into 4 segments, and it would be randomly determined by a computer whether they would be tested after each segment. So they know there's a possibility that they're going to be tested, but they don't know for sure that we're going to follow through and test them. They are all told, however, that there would be a final test at the very end of the lecture, which there was. They're also told that they're allowed to take notes on the lecture as it goes on, and that they would be probed occasionally about whether they were focused on the lecture or mind wandering. And we defined exactly what we mean by mind wandering. That's when their mind was focused on something unrelated to the task at hand, and we told them that we just wanted them to be honest with us. If they weren't thinking about focused on the lecture, they should indicate that, and that was fine. Okay, here's a schematic of the design that I just told you about. So again, you can see there are 3 groups of 16 subjects each, and everyone starts off by seeing the lecture for about 5 minutes. Everyone then does math problems for a couple of minutes, and then the manipulations are introduced. One group receiving 6 questions about the preceding segment, another group, the restudy group, receiving the same questions but also the answers, and the non-tested group keeps doing math problems. That goes on for the first 3 segments, and again, they're the mind-wandering probes during the actual lecture segment. And then in the 4th segment, everyone does math problems for a couple of minutes once again after that segment concludes, and then everyone is given a test on that final segment where were interested in the idea that the tested group, as a result of having been given the interpolated testing previously, is going to be sort of attending better to that final segment, mind wandering less, and then therefore retaining more of the information than the other two groups. That's the key hypothesis that we're testing. And here are the results. This is from experiment 2 in that paper, which is basically a replication and extension of experiment 1. If we look at the panel on the left first, the data for mind wandering, if you look at the two blue bars on the right for the restudy group and the non-tested group, what you can see is that we closely replicate the findings that I talked about earlier from classroom and video recorded lecture studies. About 40% of the time, the subjects are telling us that they're mind wandering. They're not focused on the lecture, but we're able to cut that in half in the interpolated testing group. They're only mind wandering about 20% of the time. I mentioned that the participants are allowed to take notes during the lecture, and as you can see, the folks in the tested group are doing a lot more of that, about 3 times as many notes that they're taking as the individuals in the restudy and non-tested group. And then finally, the most critical thing is that when we look at the proportion correct responses to questions that are asked about that final segment of the lecture, new questions they haven't encountered before, we see a significant benefit for the tested group, up over 80% correct, whereas the restudy and non-tested groups are down around 60% correct. And it's striking again that in the restudy group in particular, that providing the questions with the answers really is of no benefit here. The reason we think why the testing is a benefit, because that is in motivating the subjects to attend more closely to the lecture content, because they know that they're going to be asked about it later on. A few additional findings. We observed significantly higher levels of retention on the final test of all 4 segments that was given 5 minutes after that test of segment 4 for the tested group, up around 86% as compared to either the restudy or non-tested groups at 66 and 72% respectively, didn't differ from one another. Interestingly, we thought the participants in the tested group, when we asked them how anxious they felt about the final test just before we gave them that test, reported feeling less anxious. Apparently having been quizzed about along the way helped them to feel more comfortable about taking that final test. And finally, we also asked participants in all conditions about how cognitively demanding their experience of learning the lecture was, and we found that the participants in the tested group rated their experience of learning the lecture as less cognitively demanding than those in the restudy group or in the non-tested group. So it seemed to be pretty positive findings all around. That led us to do a second set of studies using more or less the same paradigm that I just told you about, but now asking about a metacognitive measure known in the literature as judgments of learning. Judgments of learning are basically our subjective assessments of how well we think we've learned a particular material. So some people, when they're hearing the lecture, may think that they're learning it really well. Others may think they're having a hard time grasping what the lecture is all about, and that would be reflected in a judgment of how well people think they've learned the material. Now, these are important because it's been shown that judgments of learning can have a causal influence on study behavior, as summarized in a nice current directions in psychological science review by Janet Metcalf back in 2009. And the general message is that if we think we have learned the material really well, even though we haven't learned it so well, we can become overconfident, and we may stop studying or reduce studying, even though we need to continue studying. And of course, the result would be detrimental effects on subsequent learning and retention. So with respect to video recorded lectures, judgments of learning were of particular interest here because there is some evidence from the previous literature that people may be prone to overestimating how much they learn from video recorded modules. It's not entirely clear why, but there's at least some evidence to suggest that you may be particularly prone to overestimating the amount learned when you're learning in a from a video recorded module. And the idea was that interpolating tests along the way should provide participants with feedback that would be helpful for them to calibrate their predictions of how well they're learning the material and reduce any overconfidence that might exist otherwise. So here's the setup. In this experiment, we've got just two groups, the tested group and non-tested group. The basic structure of the experiment is as before. Everybody's getting roughly 5-minute segments of that same stats lecture. They all do math problems for a couple of minutes, and then the manipulation is that the tested group gets asked questions about the preceding segment. The non-tested group continues to do math problems. Now, the critical measure here is taken after a 5-minute break, when we then give the final test and we ask participants how well you're going to do, make a judgment of learning on a scale from 0 to 100. 100%, I think I'm going to get everything. 0%, I don't think I'm going to get anything. So let's look now at the final test performance, both the actual performance and the predicted performance. For those who want to read up on the details of this study, it's recently published in the Journal of Applied Research in Memory and Cognition 2014 with Carl Spooner and Helen Jing, and that's actually a special issue devoted to the testing effects. So if you're interested in this work and related work, that would be a good place to look. So let's see how the participants did, and what we see here is a replication, even more dramatic actually, difference between the tested and non-tested groups, replicating and extending what we saw in the previous experiment. The tested group on that final test is doing a lot better, 75% correct, than folks in the non-tested group. Well, how do they think they're going to do? Well, that's where the interesting finding comes. Everyone thinks they're going to do great. So the tested individuals think they're going to recall most of them, and they do, so they're well calibrated, but the non-tested folks are falling prey to that trap of being overconfident in acquiring information from this video recorded module and grossly overestimate how well they're going to do. Okay, so let's summarize what we've talked about in this segment so far. We saw in study 1 that interpolating these brief quizzes in the 21 minutes video recorded stats lecture reduce mind wandering, increase task-relevant behaviors like note-taking, and improve retention, both on that final segment and on the final test of the entire lecture. Study 2, we just saw that when we interpolate the brief quizzes, there's a dramatic improvement in calibration between judgments of learning and actual learning as compared to people who don't get quizzed. Now we're continuing with this line of work, and here are a couple of future directions and questions that I think are interesting. These were laboratory studies, and so we want to know, consistent with the theme of this talk, from the laboratory to everyday life, do these effects hold in live classrooms or actual MOOCs, actual online courses? We're hoping to be able to address those questions, and I think there's some studies going on in other settings where people are already looking at that. An interesting, I think important question, both practically and theoretically, is whether interpolated quizzing enhances transfer of learning or just rote retention. So we've only looked at rote retention here. The participants are being tested on the exact facts or exact items that they just learned about, but would the interpolated quizzing enhance conceptual knowledge to the point where it would allow students to better transfer their knowledge to related questions? It's a very important issue, and we're hoping to be able to address that. Is this kind of interpolated testing necessary or even useful if one is using a highly engaging lecture that produces a relatively low baseline rate of mind wandering? The stats lecture we use, it's a decent lecture, but it is not what anyone would call highly engaging. It's easy to mind wander off that lecture. We've tried more recently to use a couple of lectures that seem to engage students more, produce lower baseline rates of mind wandering, and there the interpolating the testing doesn't seem to produce any further reductions in mind wandering when you start from a lower baseline, but it still does enhance retention of the lecture. And then finally, there's questions about brain networks that support the interpolated testing effect. We do a fair amount of neuroimaging research in my lab, and in fact, Carl Spooner has recently completed a fMRI study where we're asking questions about changes in underlying brain networks in the tested group as compared to a non-tested group, and the preliminary findings look pretty interesting, but not yet ready to be reported. Okay, so that's it for the first line of work. Now I want to transition to a second line of work concerning the effects of what I referred to earlier as a episodic specificity induction on remembering, imagining, problem solving, and divergent thinking. And this line of work emerges from a kind of research that we've been doing in my lab now for about 7 or 8 years that has to do with the relationship between remembering the past on the one hand and imagining the future on the other. A number of studies now over the past decade or so from our lab and from other labs have shown that there are striking commonalities or similarities between remembering the past and imagining the future. For those of you who want a detailed review of the evidence that I'm just going to go over very briefly in the next minute or two, I would point you in the direction of the neuron review that I wrote with several others shown on the slide that came out a couple of years ago. But to summarize some of the main conclusions in that review, we now know that many amnesic patients, that is, individuals who have significant problems in remembering past events as a result of various kinds of brain injury, also have problems imagining their personal futures or even imagining novel scenes. Not all amnesics seem to have this problem, but quite a few of them, now the literature shows, do have common deficits in remembering the past and imagining the future. Cognitive studies have shown that various experimental manipulations similarly impact remembering the past and imagining the future. To give just one example, if you ask people, for example, to remember a recent event, their memory for that event as compared to an event from the more distant past will tend to be more vivid and detailed. Well, the same sort of thing happens when you have people imagine future events. Their imaginations of events that might occur in the near future, let's say the next few days or weeks, tend to be more vivid and detailed than their imaginations of events that might occur in the more distant future, years or decades from now. There are a variety of studies, and I'll talk about a little bit of this in more detail in a couple of minutes, on aging and some from psychopathology that have shown that healthy aging, normal aging, abnormal aging, such as Alzheimer's disease, depression, schizophrenia, post-traumatic stress disorder, all of those have been associated with reduced retrieval of episodic detail about past events. So episodic details being who was in a memory, where did it happen, exactly what happened. Individuals in all these categories tend to report sketchier episodic or autobiographical memories than matched control subjects. And what's striking now is that quite a few studies have shown that the same pattern holds when you ask these same individuals to imagine future events. they contain typically these imagined events, less episodic detail about what might happen, where it might happen, how it might happen, and so forth, exactly as is seen in remembering. And then finally, a number of studies have shown using neuroimaging techniques such as mainly fMRI, that similar areas are active when people remember the past and imagine the future. We've done a lot of this work in my lab, and what we have found and others have found as well is that there is a network of regions that in this 2007 Nature Reviews Neuroscience paper with Donna Addis and Randy Buckner, we refer to as a core network of regions that comes online to a largely similar degree when people remember past events, imagine future events, and engage in related kinds of mental simulations. You see these midline regions such as the retrosplenial cortex, precuneus, posterior cingulate, and more anterior midline regions such as the medial prefrontal cortex come online very robustly. And similarly, when you remember the past, imagine the future. The medial temporal lobe, including the hippocampus, shows this effect, as do lateral parietal and lateral temporal lobe regions. So all of those kinds of evidence together suggest a very important link between remembering the past and imagining the future. Thinking about some of this work in relation to other things that we know about memory, particularly constructive aspects of memory, Donna Addis, pictured in the slide here, and I, in a couple of papers in 2007, put forth what we refer to as the constructive episodic simulation hypothesis. And basically, our idea is that a lot of these similarities between remembering the past and imagining the future reflect the influence of episodic memory on imagining future events. Episodic memory, of course, as people know, is a term that was coined by Endel Tulving many years ago and was initially used to refer to recollection of specific past personal experiences. But Tulving himself realized early on, and we and others also believe, that episodic memory plays a key role in imagining possible future scenarios. We sometimes refer to that as episodic simulation. We draw on our episodic memory in order to run simulations of the different ways in which future events might play out based on our past experience. So in the terminology that Addis and I use, we would suggest that episodic memory supports the flexible retrieval and recombination of elements of stored episode to construct possible future episodes referring to novel events. And we think that this kind of flexibility in memory that allows us to recombine elements of the past to generate and run simulations of different ways in which the future might play out is very adaptive when we're attempting to use memory for future simulation. And we think that is a major function of episodic memory, that it's really designed to help us simulate and predict the future based on past experiences, but that very flexibility can also result in memory errors when elements of past experience are miscombined. And we know from the literature that this is a very common kind of memory error where people miscombine elements of the past into events that never happened. We've seen a dramatic potential example of this recently with the highly publicized case of Brian Williams, whose memories of the Iraq War are clearly inaccurate. He seemed to have miscombined a number of things into a memory of being struck by a grenade that never happened. It's still not entirely clear whether this was deliberate deception on his part, or was he just the victim of a classic or kind of memory conjunction error, if you will, or miscombination of information for this highly arousing event. But regardless of what the ultimate status of Brian Williams is, we know from the literature that these kinds of memory errors are very common, but in our conception, we think that's a price we pay for a flexible episodic memory that's very useful for generating simulations of the future that require recombining information. Now, in a 2012 paper in American Psychologist, I tried to argue that episodic memory and simulation support various kinds of future thinking and other functionally useful processes, including planning and problem solving. So using episodic memory in this flexible way is something that benefits us in a variety of ways that aren't traditionally thought of as memory tasks. That then leads to the question of whether episodic simulation and processes such as problem solving that sometimes depend on episodic memory could be improved by targeting episodic retrieval mechanisms that support memory and simulation. So it's a concern with that question and some other issues that I'll mention in a minute that has led us recently to a new line of work on episodic specificity induction. And these are studies, first studies published just this past year in the Journal of Experimental Psychology, studies run by a graduate student in my lab, Kevin Medor, picture shown here in the slide. And let me tell you about what this episodic specificity induction is and kind of the basic logic that we're using when we implement it. So the induction is a sort of brief episodic retrieval training that helps someone adopt a specific orientation toward remembering past events. And we're interested in the question, if we can get someone to adopt this specific orientation, how does that then spill over to their performance of other tasks, including autobiographical memory, imagining the future, problem solving, as we'll see. And what we used as our induction is something that people may be familiar with. It's fairly well known in the literature. It's known as the cognitive interview. It's developed by Ron Fisher and Ed Geiselman over 20 years ago at UCLA, and is a forensic protocol which has been shown to increase accurate episodic retrieval in eyewitnesses, and is actually used fairly widely by police departments as a way of getting people to recall details from the past without producing a lot of false alarms. And we use it not because we're really particularly interested in increasing accurate episodic retrieval, but rather as a way of targeting episodic mechanisms selectively. So in our first experiment, we tried to see whether giving a cognitive interview prior to tasks involving remembering, imagining, and describing a picture could target the operation of episodic mechanisms during remembering and imagining and dissociate those from describing a picture of an everyday scene, which is a task that does not require and shouldn't recruit episodic memory. But our idea is that imagining the future does depend on episodic memory, and therefore if you've just had an episodic specificity induction that gets you to focus more on episodic details, there should be detectable effects of that when you later on imagine a future experience as opposed to just describing a picture of an everyday scene. So these are examples of the pictures that we used in the description, memory, and imagination conditions. So for example, in the memory condition, this is after you've received an episodic specificity induction or a control induction, and I'll say more about those in a minute. You'd go on to a second part of the experiment where I would show you one at a time a picture of an everyday scene. And in the memory condition, for example, if we focus on the picture on the upper left of the beach, I might say, try to remember an experience from the past couple of years that is in some way related to this picture. And so you might remember your vacation to a beach on Cape Cod last summer. In the imagination condition, I would show you another picture, and for example, the one on the lower left of people in a mall, and I would say, try to imagine an experience that could plausibly occur to you in the next couple of years that is somehow related to that picture. And so you might imagine going to the mall and shopping for a birthday present, and you would fill in the details of the imagined scenario. And then finally, in the description condition, I've just asked you, tell me what's going on in that picture. So if it was the one on the upper right, you might say there are a lot of people, they're dancing, there's a man in the forefront with a woman wearing purple and black and so on. We just want you to tell us exactly what's in the picture. So those are the three main conditions, and we're looking to see how episodic specificity induction given prior to these three tasks affects performance when remembering and imagining and describing. So here's the method. The study included 24 college students and 24 healthy, intact older adults, average age in their mid-70s. There were 2 sessions spaced 7 days apart. It's a within subjects design. So in one session, you get a specificity induction. In another session, a week later, you get a control induction or vice versa. So session 1, you would see first a short video. It's a video of people doing routine activities in a kitchen. It's not really critical what the content of the video is. It could be of anything, but it happens to be of people doing routine activities in a kitchen. I then give you an induction, either a specificity induction, which is the cognitive interview. I'll run through that in a minute, where you try to remember that video in great detail, or a control induction, where I just ask you for your general impressions of the video. And then after that, you move on to an ostensibly unrelated part of the experiment, where I'm showing you now those pictures of everyday scenes, one at a time, that we saw before, and asking you to either remember a related experience, imagine a related experience that might occur in the future, or just describe what's in the picture. You then come back a week later, and you see a slightly different version of the video. You get whichever induction that you didn't get a week previously. If you had the specificity induction in session 1, you get the control in session 2, vice versa. And then we show you a different set of pictures. And again, we ask you to either remember, imagine related experiences, or describe what's in the picture. Let's look at the inductions. The specificity induction, coming from the cognitive interview, contains mental imagery probes, tell me more probes, where we try to get people to pull out more details from their memory of the video, temporal order probes about the order in which events occurred in the video. And here's kind of just to give you a feel for what they're being asked to do. I want you to close your eyes and get a picture in your head about the people in the video you saw. I want you to think about what they looked like and what they were wearing. Once you have a really good picture, I want you to tell me everything you remember about the people in the video. Try to be as specific and detailed as you can. And that goes on for about 4 or 5 minutes as they try to remember the video. In the control induction, again, that's given a week in a separate session, a week separate from the specificity induction. They're just asked to give us their general thoughts, impressions, and feelings of the video. What were your impressions of the people? Did you like the video? When do you think it was made? So they're thinking back to the video, but they're not retrieving episodic details. And then the main task involves 18 pictures in each session. Six of them you're remembering related experiences, 6 you're imagining, 6 you're just describing pictures, and you have 3 minutes for each picture. And the critical thing here is that we then score these pictures according to a scheme developed in Levine et al.'s 2002 autobiographical interview. That provides a way of coding the protocols that we get. People are talking out loud during these tasks, and everything is transcribed, into 2 major kinds of details, internal details and external details. We look at memory and imagination. Internal details basically correspond to episodic details, the who, what, where, and when of what happened. External details refer to facts and commentary. So an internal detail would be something like, I remember when I was on the beach that the waves were large and the sun was really bright that day. Those would be coded as internal details. If you said something like, I usually don't like to go to the beach, that would be coded as an external detail, fact or commentary. For picture description, a similar scheme is used, but now an internal detail is scored for a detail that's actually in the picture, something that is present in the picture, and an external detail refers more to inferences and off-topic information. The important thing for this study and other studies like it that we and others have done is that we get very high agreement between independent blind raters who code these, over 90%, Cronbach's alpha. Okay, so again, that's what those pictures look like. Let's look at the data. And first, let's look at the data collapsed across the two inductions. So there's no effect of specificity induction here. Basically, this shows that irrespective of the induction, older adults provided fewer internal and more external details than young adults in all three tasks. So the older adults are remembering fewer internal episodic details in the memory condition. Their imagined scenarios have fewer internal episodic details, and when they describe a picture, they tell you less about what's actually in the picture than the younger folks do. And in all three conditions, they provide more external details, more commentary, reflection, things of that nature. But now the question that we want to ask, because that is actually a replication of some earlier work from our lab led by Brendan Gesser that had suggested that similarities between memory and imagination might not really reflect the influence of episodic memory so much as the influence of a more general narrative style. So maybe older adults just talk about experiences differently. That shows up in memory and imagination, sure, but it also shows up in picture description. But as we're now going to see, we can, in fact, dissociate the memory and imagination tasks on the one hand from the picture description task on the other in both old and young adults, even though the effective aging is similar on all three tasks. So the main result of the episodic specificity induction takes the form of a three-way interaction whereby the specificity induction is selectively boosting internal but not external details on memory and imagination tasks. So it's hitting the episodic details that you remember and imagine, but it has no effect whatsoever on picture description in either young or old adults. So here are the results, and if you look at the memory and imagination tasks, what you can see is that after the specificity induction, the blue bars, both old and young are reporting more internal or episodic details when they remember past experiences and when they imagine future experiences after a specificity induction than after a control induction. So indeed, the induction is doing its job. It's boosting episodic imagination and episodic recall, but it has no effect whatsoever on picture description. That seems to be relying on a different sort of mechanism. So this indicates that the specificity induction can really target the episodic retrieval in a specific way, and there's just no effect on external details at all. So it really is specific to internal episodic details in memory and imagination. So the conclusion, as I just said, is that the specificity induction selectively targets episodic retrieval and dissociates episodic retrieval from both semantic retrieval, which we think would be reflected with, associated with external details, which are not affected at all by the specificity induction, and it also dissociates episodic retrieval from non-episodic narrative processes that are most likely operating in the picture description task, which is not affected by the induction. Well, based on this observation, we can now go on and use the specificity induction to try to identify the contribution of episodic retrieval to cognitive tasks that we don't usually think of as episodic memory tasks. This can tell us whether episodic memory is indeed playing a role in such tasks. And I just want to close by telling you about one of such line of work where we've extended the specificity induction to the phenomenon of means-end problem solving, sort of open-ended everyday problems, which has been linked in some earlier work to episodic memory. And we've asked the question, can the specificity induction target and enhance episodic retrieval and thus improve means-end problem solving performance in both young and old adults? So let's go briefly into a little bit of the background here. Means and social problem solving in the literature originates from the work of Platt and Spivak, or is best known in terms of the work of Platt and Spivak, who came up with a task that requires people to generate steps that comprise solution to a variety of everyday social problems, handling an interpersonal situation at work, dealing with friends, meeting people, things of this nature. And there is evidence from an interesting study carried out by Sidney Sheldon in Morris Moskovich's lab that older adults produce fewer relevant steps when given one of these tasks, steps that lead to a solution, than do young adults, and that the deficit here, the age-related deficit on this task, is correlated with reduced episodic detail and autobiographical memory, suggesting that episodic memory may be supporting performance on this task in the same way that it's supporting performance, let's say, in imagining the future. So that led us to predict that the episodic specificity induction would enhance problem-solving performance in both old and young adults. And I'm just going to quickly summarize the study, another one led by Kevin Medor that just appeared in Psychology and Aging. So the social problems from Platt and Spivak take this form. Jay noticed that her friends seemed to be avoiding her. Jay wanted to have friends and be liked. The story ends when Jay's friends like her again. You begin where Jay first notices her friends avoiding her, and you've got to now generate steps that produce the happy ending to the story. So a relevant step would be something that moves the protagonist toward the goal. So maybe if someone says, Jay asked one of her friends what was wrong, that would be a relevant step. An irrelevant step is something that moves the protagonist away from the goal. So if you said, for example, Jay joined a new club to make friends, that really wouldn't solve the basic problem of why her friends are avoiding her. And no steps are kind of repeated information, commentary, and so forth. Here are some other means-end problems from Platt and Spivak. Some of these, like stealing a diamond and getting revenge for a spouse's death, don't seem highly relevant to the everyday lives of most people. And so we tried to come up with our own set of means-end problems to use in this experiment, involving personal goals that in a separate study were judged as relevant by both young and old, and they're phrased in the first person. So these are some of the means-end problems that we use, self-relevant problems. Turns out that we got the same results for both the standard Platt and Spivak problems as well as these self-relevant problems. The design is pretty much the same or very similar to what I just told you about in the previous study. You see that video of people in a kitchen. You get either a specificity induction or the control induction, as we discussed, and then you get a series of these means-end problems. And we also do memory and imagination tasks along the lines that we did in the previous study, just to make sure that the induction is working as expected. And then the subjects come back a week later, they get another version of the video, get whichever induction they didn't receive in the preceding section, and get a new set of means-end social problems and memory and imagination tasks. The memory and imagination tasks yielded the identical pattern of results as in the previous study. I won't show you the data other than to mention that the specificity induction once again increased internal but not external details for both young and old adults. If we look at the data from the means-end problem-solving tasks, first collapsed across the two inductions, so this is irrespective of induction. What we see is that for both the standard means-end problems of Platt and Spivak and the self-relevant ones, older adults produce fewer relevant steps than do younger adults. So that's a replication of what Sheldon and her colleagues found in the previous study that I mentioned, and there was no difference in the number of other steps. The critical new finding is that when we look at the effects of the specificity induction as compared to the control induction, what we see is a significant boosting of relevant steps in both young and older adults. They're producing more relevant steps in solving both the standard and personally relevant means-end problems following the specificity induction than the control induction. So just to conclude then, the results from the specificity induction certainly support our hypothesis that episodic retrieval contributes to future imagining and also means then problem solving. In more recent work, we've demonstrated the same kinds of effects of the episodic specificity induction on a widely used test of divergent creative thinking known as the alternate uses task. This is where you've got to generate different or unusual ways to use a common object. And what we have found in some work currently under review is that you come up with more such uses if you've just had an episodic specificity induction than if you've had the control induction. So questions we now want to answer are, how can we best address the episodic processes, best characterize the episodic processes targeted by the specificity induction? What are the key elements that make it work? What brain networks and regions are involved? We're just beginning an fMRI study looking at the effects of the induction. And in addition to using the induction as an experimental tool to identify the contribution of episodic retrieval to various cognitive tasks that we don't think of as typically memory tasks, but may be influenced by episodic memory, we also want to extend now into everyday life and see whether effects of this induction can be documented on the performance of everyday tasks. So thanks for your attention. I want to acknowledge contributions of people in my lab, collaborators, and funding sources, and hopefully I've left time for a few minutes for questions.
Certainly. Thank you so much. Now I'll give a few minutes. If you want to ask a question, you'll find the raise hand button at the bottom of your participants panel. If you click the drop down at the top, click participants, you'll see the little hand at the bottom. You can click that, and I'll unmute you to ask a question, or feel free to send me a message via chat, and we can ask that way. And don't be shy. And while we're looking for those to come through, I'm going to go ahead and put my slides back up. Okay, I'll give it about one more minute for any questions that people might have. Okay, first question in. This is from Dave Baskind. Sorry if I mispronounced your name. Memory has been in the news lately with Brian Williams' memory lapse that some suspect is fabrication. What are your thoughts?
Well, it is a very interesting question. Yeah, I think that the sort of immediate response from most people has been to assume that he's lying. A variety of psychologists have weighed in on this topic. I've been interviewed on a couple of times, and most people have said at least consider the possibility that it could be a believed-in false memory, because we know, as I discussed earlier, elements of past experiences can be miscombined. We know that the act of retrieving a memory has a powerful effect on subsequent memory, and if you start retrieving it in a distorted way and tell that story over and over again, you may come to believe something that wasn't true. We know that memory distortions occur not only for laboratory wordless paradigms, but occur for everyday autobiographical memory. There's a whole false memory literature that's built up over 20 years showing, for instance, that people can claim to remember being subject to a vicious animal attack that never happened. There's evidence that people can, the Lost in the Mall study from Loftus from many years ago. People claim to remember being abducted by aliens and being abused in satanic cults, even when these things apparently didn't happen. And there's a study coming out in Psych Science where roughly 70% of undergraduates were induced to falsely remember committing a crime when they were adolescents. So it's no surprise that people can have false memories for even emotionally arousing events. Now, does that mean that that's what happened in this case? No, not necessarily, just that it should be considered as a possibility. If, for example, a pattern turns up where you see this kind of thing in many other events that might tilt you more toward the intentional deception side, Another point, however, that I think is worth considering here is that even if it is a believed-in false memory, it doesn't necessarily fully excuse the behavior because, people who are reporting the news should be adopting a fairly stringent criterion. And there's a question of, should one even be relying on that? Shouldn't you be checking the objective record? Because we know memory can be unreliable. And, we know about egocentric biases in memory. People remember the past in ways that sort of make them look good. And that could be happening here as well. And, it may be revealing something about the way he is sort of oriented toward his job. So I don't know the final answer. The false memory explanation should be considered. More facts have to come out. But even if that is the final analysis, it doesn't necessarily excuse the behavior.
All right, thank you, Dan. We do have another question from Stephanie Davis. She asked, would there be a difference in test results based on whether or not the interpolated testing was quote-unquote graded? So if students knew the interpolated test counted towards their grade, do you think this would affect the results in any way?
That's a very good question. I tend to think it would probably enhance the effect. I mean, after all, nothing really hinges on it for the participants in our experiments other than they want to do well. They don't want to do poorly. We haven't specifically manipulated that in experiments yet. I should mention that in a cognitive neuroscience introductory lecture course that I teach with other faculty member here, we have used the interpolated quizzing live in the classroom for the past couple of years with a portion of one's grade dependent on it. It seems to function well in that it gets students to show up at lecture. And the quizzes that we give are very easy. So if you show up and you're paying attention, it's an easy way to add to your grade in a positive way. But we haven't really done the controlled studies that would be necessary to determine whether it's enhancing the effect or not. I suspect it would, but I don't know that for an experimental fact.
Okay, that sounds good. And I know we're over time, so I'm just going to go ahead and wrap up really quickly. Feel free to continue sending me questions via chat, and I will get them over to Dr. Schacter, and we can get a response to you. We are offering CE credits as part of today. The code is S0210. So that's there for you in case you want it. And we'll be following up with the PowerPoints that Dr. Schacter used today, as well as a link to the recording. So you can go back and reference it, send it to a colleague, or maybe show it to your students in class if you find that needed. Lastly, feel free to follow us on Twitter at WorthPsychTLC for fun teaching updates every day. Thank you guys so much, and thank you so much, Dan Schacter, for taking the time out of your schedule to speak. Thank you, guys.
Hey, thank you.